The teacher's role in inquiry mathematics instruction. Inquiry mathematics instruction is dependent on successful implementation by the teacher. We have included some discussion of these aspects of the teacher's role throughout the 3 videos that detail the instructional activities that comprise the structuring numbers instructional sequence. In this 2-part video, we highlight 2 aspects of the teacher's role: instructional planning and conducting productive class discussions. Before we get into the specific details of the teacher's planning activity, we explain principles that guide her planning. The first principle is that every student should have a personally meaningful way to participate in every activity. In any classroom, children are at differing stages of conceptual development, and with that in mind, lessons are designed so that each child has some meaningful way to participate in each activity. In other words, the teacher does not select activities that only some children are able to participate in. Each child participates in every activity, but does so in a way that makes sense to him or her. Some children participate in more sophisticated ways than others, but each child participates in one way or another. And that brings us to the next principle. Every student should have an opportunity to advance in his or her learning in every lesson. That means that lessons have to include activities through which all students can advance, including those students that are more conceptually sophisticated. Yet these activities have to also be doable in some meaningful way by everyone in the class. The less sophisticated students will participate in these activities, but will use more primitive methods that are appropriate for them. In other words, all students participate, but they do not all participate in the same ways. The reason it is possible to plan lessons based on both of these principles simultaneously is that the instructional activities in the inquiry sequences we use are designed to promote conceptual development, not teach specific topics or skills. By that we mean that students make advances in their concepts of number and in the ways they reason through engaging in the activities. The goal of an activity is never that students learn to do the activity or complete it in a certain way. Rather, it is that all students will advance in their conceptual understanding of number as they engage in the activity. And as they advance, they are able to complete mathematical tasks and solve mathematical problems. One implication of our approach is that the teacher has to pay close attention to the ways the students in her class reason and solve problems. And she has to think through what that means about the current conceptual understandings of the class as a whole and of specific individuals within the class as she makes decisions about which instructional activities to use in each lesson she plans. In other words, the teacher's instructional planning is driven primarily by the current thinking and reasoning of the students in her class rather than by preset timelines or outlines. This requires that the teacher reflects daily on how the lesson transpired and uses that as input for planning the next day's lesson. A final principle of lesson planning is a pragmatic one, and it is this. It is useful to include activities that provide a variety of formats within a lesson, such as whole class activities and, when appropriate, partner activities or game-type formats. To reiterate, lessons are designed to engage all children at their own level of conceptual development and to provide opportunities for all children to advance in their learning. We now illustrate this approach to planning with 2 examples. First, we illustrate how the teacher makes decisions about which activities to include in the lesson. A lesson from Structuring Numbers Part 1, Becoming Efficient with Reading the Rack. Let's think through what the teacher takes into account as she plans this lesson. Her students have been working with the arithmetic rack for several days, so have worked through the introductory activities and have already spent several days working on becoming efficient at reading the rack. In fact, by now most students in the class have already started to use the color groupings of the beads to figure out the quantities shown. As she reflects on how her students have been engaging in the activities, the teacher considers what they currently understand and what understandings they still need to develop. She thinks about Maria, for example, who after these few days already capitalizes on the color configurations of the beads. Maria sees groups of 5 red beads or 5 white beads, recognizes them as 5, and immediately knows that 2 groups of 5 beads like this make 10. She counts on by 1 from 10 to get the total to account for any additional beads beyond those in groups of 5. Maria does not yet know the relationship between 10 and the team numbers. By that I mean that Maria does not yet just know that 10 and 3 are 13 or that 10 and 7 are 17. She counts on by 1s from 10 to figure that out. So instructional activities, such as those shown here, that involve reading the rack where the total shown is a team number that includes 2 groups of 5 beads of uniform color, will be particularly beneficial for Maria's advancement. The teacher anticipates that in tasks like these, Maria will immediately recognize the 2 groups of 5 beads total to 10, and then will count on to figure out the total number of people on the bus. The teacher also knows from experience that students like Maria develop the relationship between 10 and the team numbers from repeatedly solving tasks like this one, especially if the teacher ensures that the conversation includes comments such as, Maria figured out that there were 10 red beads, and then she saw 2 white beads and she figured out that makes a total of 12 beads. The teacher knows that there are quite a few other children in the class whose understandings are like Maria's. They recognize groups of 5 beads, easily combine 2 groups of 5s to get 10, but count on beyond 10 to account for other beads. However, the teacher is also aware that 1 or 2 students already just know the relationship between 10 and the team numbers. These few students do not count on by 1s from 10 to figure out the total. They figure out how many beads there are beyond 10 and then just know the total is the relevant team number. The teacher also knows that 2 or 3 of her students still count all of the beads by 1s. Armando is one of them. When asked how many red beads or how many white beads on each rod, Armando will answer 5. But he cannot yet use that information to solve a task because he has not yet developed the concept of 5 as a composite unit. That means that the only way he can use a 5 is to first create it by counting 1 by 1 from 1 to get to 5. Armando will not be able to read the rack efficiently until he develops 5 as a composite unit. Armando will benefit greatly from tasks where he has to show a quantity under 10 on each rod as part of the task, because every time he counts such a group, he will be at 5 when he has counted all of the red beads. Eventually, he will make that realization and will then no longer need to count each bead to get to 5. He will have developed the concept of 5 as a composite unit. That is, 5 is a thing, an entity in and of itself. So the activity where the teacher tells the students the number of people on the upper deck of the bus and the number of people on the lower deck of the bus, the students have to show that on their racks and then figure out how many people are on the bus, will provide important learning opportunities for Armando. So with this information in mind, how might the teacher decide which instructional activities to include in the lesson? She decides to include the activity where students have their racks. She tells them how many are on each deck of the bus. The students show that on their racks and then figure out the total. She plans to select tasks where the number on each deck is 5 or more. Armando and those students like him will especially benefit because they will have repeated opportunities to encounter groups of 5. The same activity has potential benefits for Maria and those students like her as well because they will encounter the type of tasks they need to engage in repeatedly. They will easily see 10 and then have to figure out the team number that is the total. The 1 or 2 most sophisticated students in the class might no longer learn anything new from this activity. Even so, their contributions to the discussion will be useful to everyone. To ensure that these high flyers also have opportunities to advance, the teacher decides to include the rack flash activity. In this activity, students do not have their racks, but they see an image of the rack that the teacher flashes on the screen. The student's task is to figure out how many people are on the bus from the image flashed. These students will develop mental imagery for quantities to 20 based on the color configurations. That is, images that are 5 referenced, 10 referenced, and doubles referenced. This instructional activity is also beneficial for Maria and those like her because they will quickly develop mental imagery for groups of 5 and 10 and will be able to use that mental imagery to go beyond 10 to get to the teen number. And in keeping with the principle that every student should have a personally meaningful way to participate in every activity, the teacher will make sure that Armando and those few students like him have a rack to use during the Rack Flash activity. These students might not be able to complete the entire task before the discussion begins, but they will be able to move the beads on their racks to show the same configuration the teacher has flashed. And during the discussion, these students will be able to use their racks to continue to solve the task and to make sense of the accompanying discussion. Both of these instructional activities are whole class activities. To provide variety in the format, the teacher decides to use a partner activity. In partner work, children have an opportunity to be more physically active and necessarily are fully engaged. In this case, the teacher's choice is to use the partner version of the first whole class activity she has planned. In this activity, the partners take turns being the teacher, posing tasks to each other. The activity will provide additional opportunities for all of the students to advance their learning because they get to choose the difficulty level of the tasks they pose to each other, and because with partner work, children tend to pose many tasks to each other within a short amount of time. The teacher decides to use this activity second in the lesson. So now her overall plan looks like this: whole class activity, then the partner version of that activity, and then another whole class activity, Rack Flash. In keeping with our recommendation, this teacher typically devotes close to an hour to each math lesson. So she plans on having students engage in each of the 3 activities for a little more than 15 minutes. That allows for a few minutes of transition time between activities, including getting out and putting away the racks as needed. Teachers typically use a plan such as the one we have just shown in example 1 for several days, possibly a week or more, before adjusting it by omitting one or more of the activities in the lesson and including one or more activities that are more conceptually challenging. In this way, the teacher organizes lessons to gradually progress through the sequence. In essence, the sequence evolves. For additional discussions of this issue, see the concluding slides of each of the videos, Structuring Numbers 1, Structuring Numbers 2, and Structuring Numbers 3. We want to emphasize again that by providing increasing conceptual challenges within a lesson, the teacher ensures that every child has an opportunity to advance in each lesson. At the same time, because each child participates in a way that is personally meaningful, some children will use solution methods that are less sophisticated than others. For example, in some cases, the teacher will make sure that children that need racks will have them to use, while other children will not have access to a rack for that same activity. Teachers that use the Structuring Numbers instructional sequence successfully typically make gradual shifts in the activities they use. The lesson shown in this second example illustrates this point. This example is from Structuring Numbers Part 2, Becoming Efficient with Adding and Subtracting Using Grouping Strategies Prompted by the Rack. The teacher might use this lesson after students have been working with the Reasoning by Moving the Beads activity for several lessons. She knows from experience that after just a few days of using Reasoning by Moving the Beads activity, many children move the beads to show the number of people that get on or off the bus in very efficient ways that result in configurations that can be easily read by using the color configurations. Their activity appears to be purposeful. This suggests that such children know before they move the beads which one they will use to complete the task. At this time, it is appropriate for the teacher to introduce the anticipation task. It is easy to do. After posing several tasks where children move the beads to complete the task, the teacher can begin to pose the next task in the same way, but after students have shown the initial quantity on their racks, she can say, "This time, instead of moving the beads to show what happens, just think about how you would move them and figure out what the result will be." What the anticipation activity does is call explicit attention to the ways children think about the second part of the task. Which beads would they move to show that more people got on the bus or some got off the bus? In the discussion of the task, the teacher asks the children to talk about which beads they would have moved to complete the task and why they would have moved those beads, in addition to talking about how they figured out the result. Doing so requires that children articulate their reasoning using language that others can understand. That means that they have to be able to verbally express any mental imagery that might be guiding their actions. The result is that those children that are still touching and moving the beads to complete the task become explicitly aware of how choices of which beads to move lead to various grouping strategies. In this way, these children gradually also develop the ability to anticipate the results without actually completing the task with the rack. In other words, the anticipation activity provides opportunities for all of the students to advance. The more sophisticated children advance as they make their thinking and reasoning explicit, while the less sophisticated students advance by listening to and attempting to make sense of what others say, while also having the opportunity to complete the task by moving the beads if necessary. Most teachers would plan a third activity for this lesson that involves a different format, such as a pairs activity or a game. In our experience, teachers often include an activity of that type from an earlier portion of this same instructional sequence, an activity that they know still provides considerable learning opportunities for their students. Teachers typically use this overall plan for several lessons, possibly up to 2 weeks, before adjusting it by deleting the first activity and adding the activity reasoning without moving the beads. We refer you to the suggested timeline in the Structuring Numbers 2 video. A second aspect of the teacher's advanced planning is to select the specific tasks she intends to pose for an activity that she will use within the lesson. Here again, the teacher is purposeful in her choices as she thinks through the potential learning opportunities these choices provide. Again, we will give 2 examples to illustrate considerations that the teacher takes into account in deciding which tasks to plan. The first example is taken from the first part of the Structuring Numbers sequence, Becoming Efficient at Reading the Rack. In the activity in this example, the teacher tells students how many people are on the upper deck of the bus and how many are on the lower deck of the bus. Students show each of those amounts on their racks and then figure out how many people are on the bus in total. Recall that this is not an addition task. Rather, students are expected to use the beads on their racks to figure out the total by capitalizing on the color configurations of the beads. For this reason, it is important that the teacher choose numbers that result in configurations that can be read, that is, figured out efficiently. In the following discussion, we illustrate the teacher's thinking process as she chooses which tasks to pose. The first task the teacher plans is 6 people on the upper deck and 5 on the lower deck. She plans this as the first task because she expects that children like Maria will figure out that there are 11 people on the bus by combining the 2 groups of 5 red beads, the 5 red beads on the top and the 5 red beads on the bottom, to get 10, and then know that the total is 11 because there is also 1 white bead. The teacher expects that Maria's explanation will be useful to Armando and those children like him that did not use that approach but instead counted the beads. They will take note of that explanation, attempt to make sense of it, and some of them will be able to use that way of reasoning if presented with a similar task. Therefore, she plans for that possibility. The second task she plans to pose is 6 people on the upper deck and 6 people on the lower deck. The teacher knows from experience that more children will figure out this task by combining the 2 groups of 5 red beads to get 10, and then know that the total is 12 because there are 2 white beads. Some children will just know that 10 and 2 are 12, and others, like Maria, will count 10, 11, 12. Nevertheless, she also knows that some children, like Armando, will continue to count by ones because they have not yet developed a concept of 5 as a composite unit. She also expects that at least 1 or 2 children will solve this second task by using another way of reasoning. It's just one more than 11. There's 1 more white bead. These children are not using groupings of beads in efficient ways to solve this second problem, but are simply noticing that there's 1 more bead than last time. The students are capitalizing on the fact that they have already figured out the initial task, so all they need to do is add 1 more. The teacher plans to use 6 people on the upper deck and 7 people on the lower deck as the third task because it provides the same opportunities as the second task did. Some children will capitalize on the 2 groups of 5 red beads to get 10 and continue on with the white beads to get 13. Others will relate it to the previous task, noticing that there is just 1 more bead. So the answer has to be 1 more than 12. It has to be 13. The teacher plans another task that she might use as an alternative for the third task. 5 people on the upper deck and 7 people on the lower deck. Her reasoning for this choice is that this task again creates an opportunity for students to group the beads to get 10 and then get 12 by combining the 2 white beads. But it also creates an opportunity for children to reason there is 1 less bead on the top and 1 more bead on the bottom, so it has to be the same as last time. This is another type of relationship between tasks that students might capitalize on because of what they notice about the beads. The teacher is aware that this choice of tasks creates opportunities for children to use color configurations of beads to solve the tasks or to solve them by relating them to a prior task. These 3 tasks may take up all the time she wants to devote to this activity in this lesson because the class discussions take a considerable amount of time. However, she plans a 4th task in the event that there is time for it. Actually, she plans 2 alternatives, 4th task, should she have time for it. The first alternative is 5 people on the upper deck and 6 people on the lower deck. She expects that some children will solve this task by relating it to one of the prior tasks. For example, some might notice that it uses the same quantities as the first task, but the quantities are switched around on the rods. And she expects that other children will again combine the 2 groups of red beads to get 10 and go from there. She will use this task if time permits because it provides opportunities for both of these solution methods. The second alternative the teacher has planned as the 4th task is 10 people on the upper deck and 5 on the lower deck. She chose this task because the quantities involved in this task are not easily related to those in the prior tasks, so students will not be able to solve it by relating it to prior tasks. She plans to use this task in the event that most students are solving the tasks by relating them to one another and few are using the color configurations of the beads to solve them. She will use this task if she decides to bring the focus back to using strategies based on the color configurations of the beads. She chooses the numbers for this task deliberately. By using 10 on the upper deck and 5 on the lower deck, she makes it possible for students to combine all of the red beads, 5 from each rod, to get 10, just as some of them did for the first 3 tasks, or to get 10 from combining the 5 red beads on the top with the 5 white beads on the top, and then go on from there. So in using this task, she can bring the focus back to using strategies based on the colors of the beads, while yet providing a new learning opportunity because of the 10 on the top rod. In the 3 videos, Structuring Numbers 1, Structuring Numbers 2, and Structuring Numbers 3, we have devoted some discussion to task selection, and in some cases have talked about the benefits of sequencing tasks. In the example shown here, we have provided extensive detail about the rationale for the teacher's choices. It is important that teachers plan in advance which tasks they will pose in the lesson to maximize learning opportunities for their students. At the same time, during the lesson itself, teachers have to make judicious decisions about when to deviate from their planned sequence of tasks to capitalize on teachable moments that arise spontaneously. The second example of a task sequence a teacher might plan is taken from the second part of the Structuring Numbers sequence, becoming efficient at adding and subtracting using grouping strategies prompted by the RAC. The task sequence described here can be used effectively with any one of the activities: reasoning by moving the beads where the children use their racks, the anticipation activity where students show the initial quantity on their racks but then just imagine the rest of the task, reasoning without moving the beads where students see the initial quantity on the image the teacher shows and then complete the task mentally, or the imagination bingo task. The first task the teacher has planned is 5 people on the bus. 7 more get on. She expects that many students like Maria will use color groupings of beads to solve this task. most likely combining the 5 red beads on the top rod with the 5 red beads on the bottom rod to get to 10, and then figure out the result is 12 because there are also 2 white beads. By now, students like Armando may also have progressed to using this approach as well. The second task the teacher has planned is 5 people on the bus, 8 more get on. She chose this for the second task to provide an opportunity for students to use a strategy based on color groupings of beads, similar to that used for the first task, or to reason that this is just one more than the first task because there is one more bead. The third task the teacher has planned is 13 people on the bus, 8 get off. The teacher expects that some students will relate this task to the previous task, reasoning that it is just the opposite. In this way, this third task contributes to students developing understanding of the reversibility of addition and subtraction. The teacher knows that other students will use a strategy based on groups of beads, either taking 3 from the bottom rod, that is emptying the bottom, and then taking away the other 5 from the 10 beads on the top to get down to 5, or taking all 8 beads from the 10 on the top rod to leave 2 on top and 3 on the bottom for a total of 5 people left on the bus. Whether they actually move the beads or just think about moving the beads depends on which of the 4 activities is involved. The fourth task the teacher has planned is 13 people on the bus, 9 get off. The teacher selected this task to again provide an opportunity for students to use groupings of beads to solve the task or to relate it to the prior task. She knows from past experience that students who do not relate tasks initially often do so after they hear others reason in this way. The teacher knows that this sequence of tasks creates opportunities for children to solve each task after the first one by reasoning based on groups of beads or by relating tasks to one another based on changes they see in the beads from one task to the next. So the sequence makes it possible for children to advance along 2 different lines of reasoning. We want to reiterate here how this sequence of tasks provides learning opportunities for all students at a variety of levels to advance in their reasoning. We also want to emphasize that the goal is not that everyone sees the same relationships. This is another example of how a sequence allows for differentiation. When the teacher wants the focus of the discussion to revolve entirely around using color configurations of beads to solve the tasks, she will not use this sequence, but will instead choose tasks that have no apparent relationship to one another. We want to make one additional point about the sequence of tasks shown in the 2 examples presented here. Throughout our discussion of these examples, we have noted that the teacher's selections of tasks has made it possible for students to use the color groupings of the beads to solve the tasks or to solve subsequent tasks by relating them to prior tasks simply by visually noticing some change in the number of beads, such as a task might have 1 more bead than the prior task. At first glance, this second approach to figuring out the tasks might seem to be cause for concern because it appears that the children are relying only on a visual cue. But the point we want to make is that solutions of this type are the genesis of another type of reasoning that we want to foster, thinking strategy reasoning. We say that someone uses the thinking strategy if they use something they already know or have just figured out to solve the task at hand. Typically, we use the label thinking strategy to apply to those situations where the task is posed numerically. For example, if the child's task is to solve 6 plus 7, posed purely numerically or in a numerical setting without visual support materials, and the child says, I know that 6 plus 6 equals 12, so 6 plus 7 has to be 13. It's just 1 more. We say the child solved the task using the thinking strategy. His solution was based on reasoning about the quantities involved. A natural question is, how does the teacher promote children's development of thinking strategies? One way to do so is for her to use task sequences such as those shown in these examples. The fact that visual material is present in the posing of the tasks makes it likely that someone will notice the relationship between the tasks because of the visual cues. And through the discussion, the relationship between the quantities involved becomes explicit. As the structuring numbers sequence progresses and the visual support of the rack drops out, reasoning by relating tasks to one another becomes independent of the visual support material. In other words, in the same way that grouping strategies emerge from children's use of the arithmetic rack as they become independent of the visual support of the rack, thinking strategies emerge as well, if the teacher plans sequences such as those shown here, where visual material is initially available but later drops out. Another way to say it is that the task sequences shown in these examples provide opportunities for children to develop the basis for both grouping strategies and thinking strategies.